This question is about acidic solutions. The acid dissociation Ka for ethanoic acid is given by the expression shown. And the value for Ka is 1.74 times 10 to the minus 5 moles per decimetre cubed at 25 degrees C. A buffer solution with a pH of 3.87 is prepared using ethanoic acid and sodium ethanoate, and in the buffer the concentration of ethanoate ions is 0.136. Calculate the concentration of ethanoic acid, giving your answer to 3 significant figures. So let's just scroll down to the bottom and just write that underneath here so we don't forget when we get to the end. Then let's just have a look at all the things that we've been given. So we've been given the pH. So we're going to use that pH to calculate H+. So H+ is 10 to the minus pH. So we want to do 10 to the minus 3.87 on our calculator. So we press the shift button and then the log to the base 10 button, and then type in minus 3.87 and we get 1.35 times 10 to the minus 4. And you could give more significant figures. I'm going to keep that on my calculator at the moment. So that's given us the H+ value. We have been given the Ka value here. So let's do that again. So we have been given the Ka value, that's this value. We have been given the ethanoate ions value, which is this value here. We've now calculated the H+ value, so we need to rearrange this expression to say concentration of ethanoic acid. So if we do that, concentration of ethanoic acid, it's going to come up off the bottom line. I'm going to multiply the left-hand side by it, but at the same time I'm going to divide both sides by Ka. And because this is a buffer, everybody gets their own number. So I'm going to put the numbers in. So 0.136 times by the number off my calculator for the H+, divided by the Ka value, 1.74, times 10 to the minus 5. And if you do all of that on your calculator, you should get 1.05 when you give that to 3 significant figures. The next part of the question, it says we're still in a buffer, it's a different buffer. It gives us the concentration of ethanoic acid. So it's just, we've got ethanoic acid, that's our HA. We've got ethanoate ions, that's our A-. And then it says that we're going to add sodium hydroxide, which remember, we're only really interested in the OH-. But be careful because they're telling us it's only to 500 centimetres cubed. Now, sodium hydroxide is going to react because remember that a buffer is a mixture of a weak acid and its salt, so HA and its salt. If you add OH- to this buffer, it's going to react with the HA and it's going to convert some of it to A-. So this is a reaction where HA is going to get reduced by reacting with OH-, and we're going to make more A- and some water. We're not really interested in the water because it's not in our Ka expression. Now, because there's a reaction, we need to work in moles because we need to find out how many moles got used up, how many changed. Can't keep things in concentration. So let's convert our volumes and concentrations to moles. So we've got 0.260 and we had 500 centimetres cubed or half a decimetre cubed. So that'd be 0.130. And at the beginning in the A- we had 0.121 of A-, but 500 centimetres cubed of that, which is 0.0605 moles. And then we're being told that we've added 7 times 10 to the minus 3 moles of OH-. Now what will happen is that OH- will get completely used up. It will all react because it's much smaller than the other numbers. And in doing that, it will use up the same amount of HA. So if we subtract 7 times 10 to the minus 3 from 0.13, we get 0.123, but we'll create another 7 times 10 to the minus 3 A minus, but we already had some, so we have to add it on, and we get 0.0675. Now, theoretically, we should convert these back into concentrations for our Ka calculation, but if you remember that when you rearrange the Ka expression to find H+, you get Ka times Ha over A minus. Now in this case, you can see that we've got one concentration value on the top and one on the bottom, so even if we didn't divide by the volumes, we wouldn't get a different answer because the volumes will cancel out. So remember, we're using the Ka from the previous part of the question, 1.74 times 10 to the minus 5. We're going to times that by the Ha, 0.123, and we're going to divide it by the A minus, 0.0675. We're going to type all that on our calculator. So we're getting 3.17 times 10 to the minus 5. And then since pH is minus log of the hydrogen ion concentration, the negative logarithm of the hydrogen ion concentration, we can press minus and then the log button and then the answer button on our calculator. And it's coming out as 4.4988, but often they ask us to give our answer, which they have done here, to 2 decimal places. So we will need to round up. So there's where the second decimal place is, but this 8 will round up 49 to 50, so it becomes 4.50.